This lecture will cover the CFA Level 1 reading on elasticity. So let's get started. The first concept that we are going to talk about is that of supply and demand. And let's start here with a very basic demand curve. What you see here is a very straightforward demand curve, and to understand this demand curve, let us imagine that we are considering the cement industry in your country. Now let's assume that in our industry, initially let's say that the price of cement is $11 per unit, and at $11 per unit, let's say that the industry demand is, let's say it is about 19 million units. Now what will happen if the price of cement goes down? Let's say that the price of cement goes down to $9 per unit. What will happen to the demand? Obviously, if the price goes down and nothing else changes, the demand for cement will go up. In our simple example, let's say that the demand goes up to 21. So what you notice here is when the price of cement goes down, the quantity demanded will go up. And this is true for any item that you are analyzing, for any product that you are analyzing. When the price of that item goes down, all else equal, the quantity demanded will go up. And this explains why the demand curve will always be downward sloping. Let us now look at the supply curve. Imagine now that you are one of the suppliers of cement. Obviously, if the price goes up, you will be willing to supply more. So let's say that when the price is 19, then you are willing to, or let's say when the price is about 9, you are willing to supply a certain amount, let's say 18 million units. As the price goes up, you will be willing to supply more. Now, what is the equilibrium amount of quantity supplied and what is the market price? The equilibrium quantity and market price is determined by this point here, where the supply curve intersects the demand curve. So this point here, P0 for price and Q0 for quantity, is the equilibrium point in our industry. Now that we've understood the basics of supply and demand, let's get a little deeper into the concept of elasticity. Specifically, we will talk about the price elasticity of demand. While it's already been established that the demand curve is downward sloping, and we know that when price goes down, the quantity demanded goes up, but the question is by how much? In this picture, in the top half of the screen, we are looking at a rather steep demand curve. Now, as you will find out shortly, a steep demand curve implies that we are relatively inelastic. What does that mean? To understand this concept of elasticity, let's say that the supply curve shifts to the right. Why might this happen? Let's say that a few more companies have entered the cement industry, so the quantity supplied has gone up. Now, if there are more companies supplying cement, what happens is, if we initially had the supply curve S0, we now have a new supply curve which has shifted to the right. Now, intuitively you can recognize that if you have more supply, the equilibrium quantity will go up and the equilibrium price will go down. But by how much? And that's where elasticity plays an important role. As I mentioned earlier, this is a somewhat inelastic demand curve. What does that mean? That means that if you look at point P0, which was your original equilibrium, and compare that with this point P1, which is the new equilibrium, we had a substantial reduction in price represented by the difference between P0 and P1. So our price came down quite a bit, but the quantity increased by a relatively small amount. So this is an example of an inelastic demand curve, where even a large change in price only results in a relatively small change in quantity. Note here again that when the price goes down, so a negative change in price results in a positive change in quantity demanded. So therefore the elasticity of demand will in general be a negative number. Now compare this demand curve with a more elastic demand curve that you see in the bottom half of your screen. So a flattish demand curve implies higher elasticity. So what if our demand curve looked like this? Now given a similar shift in the supply curve, look what happens to the new equilibrium price and quantity. Originally we were at the point P0 and Q0. Now when there is an increase in supply, notice that the price goes down by a relatively small amount, but the quantity has gone up by a larger amount. So a small change in price but a relatively large increase in quantity. So this suggests a elastic demand curve. Let us now quantify the concept of elasticity. What you have understood so far is that price elasticity or demand simply gives us the responsiveness of quantity demanded to a change in price. Now let's come up with some numbers. The formula that you need to learn is that the price elasticity or demand is equal to the percentage change in quantity demanded divided by the percentage change in price, depicted in shorthand with this little formula. It's important to note that the percentage change in quantity is, as in you need to know how to calculate this. There is a small subtlety here. The percentage change in quantity is the ending value of quantity minus the beginning value divided by the average quantity. Similarly, the percentage change in price is the ending price minus beginning price divided by the average price. To understand this, let's do a simple example. And to keep things simple, we'll continue with the cement industry. Let's draw a very simple demand curve that shows us what we are. So let's draw this very simple demand curve. Alright, so remember that whenever you are drawing the demand curve, the y-axis is price and the x-axis is quantity. Demand curve, as you know, is always downward sloping. So what point are we at initially? So as the problem statement indicates, initially we are at a price of $11 per unit, and at $11 per unit we have a quantity demanded of 19 million units. When the price falls to 9, what happens to the quantity? Obviously the quantity will go up, and in our example the quantity goes up to 21. Now let's calculate the elasticity of demand given the formula we just looked at, which was elasticity of demand is the percentage change in quantity divided by the percentage change in price. So that's actually quantity. Okay, so what is this now? In our example, what is the percentage change in quantity? Our quantity changed from 19 to 21, and as we just said, the percentage change is 2. So from 19 to 21 we went a change of 2, and divided by the average of 19 and 21, which is 20. And what about the percentage change in price? Price changed from 11 to 9, so that's -2. Remember, the price went down, divided by the average of 11 and 9, which is 10. Alright, expressed in percentage terms, so you can say 2 over 20 is 10%, divided by -2 over 10 is 20%. So your elasticity or demand is negative 0.5. So this is an important concept, and very likely that you will get some question related to this on your exam. So you need to practice this calculation a few times to make sure you understand it well. Okay, so now let's look at a few demand curves. The first example here is elastic demand curve, and as you know by now, an elastic demand curve implies that when you have a small change in price, the quantity demanded changes by a large amount. So this is an example of a elastic demand curve. The next example is an inelastic demand curve where a large change in price. So a large change in price creates a small change in quantity demanded. So that's an inelastic demand curve. Now look at examples of a perfectly inelastic demand curve. So what that means is that no matter what the price, the quantity demanded stays the same. An example of this might be medicines such as insulin, where there is no real substitute, and people who need insulin will demand it no matter what the price. And obviously, demand doesn't change based on price. Demand is based on the requirement that the patient has. So that's an example of a perfectly inelastic demand curve. Let us now talk about a perfectly elastic demand curve, which is horizontal. An example of this might be, let's say, the demand for oranges in your local fruit market. So if oranges are selling in general for 80 rupees a dozen, then somebody raises his price to 85 rupees. The quantity demanded at 85 will be 0. So that's an example of a perfectly elastic demand curve. Now let's look at the relationship between elasticity and revenue. So a point that we have not fully highlighted yet, and we will do so now, is the concept that even though you are looking at a straight line demand curve over here, so this demand curve is a straight line, but the elasticity of demand, so this is your demand curve, the elasticity of demand changes as you move along this demand curve. So let's look first at the region up here. So in this region, the elasticity is going to be high. Why is that? Go back to your relationship for the elasticity of demand. So as we've seen before, elasticity of demand is equal to the percentage change in quantity divided by percentage change in price. Now in this top region, the percentage change in quantity is going to be a high number. So the quantity change from here to here is going from, let's say, 1 unit to 2 units. Alright, so from 1 to 2 is a pretty big change in percentage terms. So the percentage change is high. What about the percentage change in price? Prices might be going from, let's say, 100 down to 99. So that is a relatively low percentage change. So high divided by low is going to give you a high number for elasticity. Alright, so in the top left region you are going to have a relatively high elasticity. What about this region over here? So in this region, again the formula is the same, percentage change in quantity divided by percentage change in price, but the percentage change in quantity is now going to be low, because let's say you are going from 100 units to 101 units, so the percentage change in quantity is low, but price numbers are small. So the price might be going from $1 to 50 cents. In percentage terms, that's a big change in price. So the denominator is high. So overall, the elasticity is going to be a low number divided by a high number, which is a low number. So in the bottom region, we are somewhat inelastic. In the top region over here, we are elastic. And obviously, if the elasticity is high here and moving down, it's becoming lower and lower, at some point in the middle, we are going to be unit elastic, which means that elasticity is equal to 1 at some point. Now let's tie this demand curve to the revenue of a firm. What is the revenue when we are at this point? So as I'm sure you know, your revenue is equal to price times quantity. So when you are at the top left of the demand curve, the price is high but the quantity demanded is 0. If the quantity demanded is 0, then obviously the revenue will be 0. After that, as you move to the right, you are decreasing. As you move to the right, the price is going down. But since we are in the elastic region, the quantity is going up. The quantity is going up more than the price is going down, and hence your revenue, which is the product of price and quantity, goes up. That remains the case till we get to the point where we are at unit elasticity. Now, so at this point, unit elasticity, we maximize our revenue. What happens after this? After this, our demand curve is inelastic. If the demand curve is inelastic, what does that mean? That means that as price continues to go down, the quantity goes up, but by a relatively small amount. So what's going to happen to revenue if price is going down a lot but quantity is only going up a little? The revenue will start falling till we get to this point where the price now is essentially down to 0. So no matter how much you sell, if the price is 0, our revenue has now come back down to 0, and that explains this parabolic shaped revenue curve with the revenue maximized where elasticity is equal to 1. Note that revenue is maximized here, but this does not mean that profits are maximized. And later on in the economics course, we will talk about where profit is maximized. Now let's talk about the factors which influence the price elasticity of demand. The first factor which you need to be aware of is this closeness of substitutes. If the closeness of substitutes is high, then the elasticity of demand will also be high. Why is that? Imagine that you are in the washing machine business, and let's say you can make washing machines out of both plastic and metal. So plastic and metal are close substitutes. Now say we are evaluating the demand curve for plastic. So if we are evaluating the demand curve for plastic, what will happen to the demand for plastic if the price of plastic goes up? If the price of plastic goes up, the demand for plastic will fall a lot because firms can now easily use metal instead. So given this example, if substitutes are easily available, the change in quantity demanded will be very high even when there is a small change in price, which means the elasticity is high. So the point to remember, if you have close substitutes, then elasticity is high. The next point is how much that elasticity also depends on the relative amount of income that you spend on goods. So this again is best understood through an example. Let's say we take the example first of house rent. So a significant percentage of your income is spent on house rent. That means that even if house rent goes up by a small percentage, you are going to feel it. and if house rent goes up by say 5%, that is going to be a significant component of your income, and you will then potentially consider other options such as staying with your parents, which will reduce your demand for housing units. So the elasticity is relatively high. Compare that with the demand for gum. Let's say that one packet of gum costs 25 cents. Now, if the price of gum goes up by 50%, so from 25 cents it goes up to something like, let's say about 45 cents. How much will that impact your demand for gum? And the answer obviously is that it will not impact the demand too much, which makes the demand for gum rather inelastic. Only a very small percentage of your income gets spent on gum, so changes in price do not impact demand very much. Hence, the demand curve for gum is relatively inelastic. Now, the third point, which has to do with the time period since the change. This is the time period since the change in price. As you can imagine, if a very short time elapses after the change in price, then the demand does not change too much. But as more and more time passes, then the demand will obviously change more. Say there is a huge increase in the price of petrol. What will be the impact on demand for petrol in the short run? So in the very short run, you are likely to consume roughly the same amount of petrol. But longer term, you will try and change your behavior. You might carpool, or you might choose to use public transportation. So what will happen in the long term? In the long term, you are going to reduce your demand for petrol. So as you can see from this example, when we take a longer term perspective, then the elasticity is higher. Okay, so you need to know the 3 points shown on this slide. Now let's talk about the cross elasticity of demand. Cross elasticity of demand measures the change in demand in response to changes in the price of a substitute or a complement. We've already talked about a substitute, so we gave the example that metal and plastic are substitutes. What is a complement? Complement is two products that are consumed together. So a classic example would be pizza and soft drinks, or donuts and coffee. So when you consume more pizza, you have more soft drinks with it. So pizza and soft drinks are complements. What is the impact on the demand for a given product when the price of a substitute goes up? So going back to our metal and plastic example, remember that these were substitutes. If the price of metal goes up, what is going to happen to the quantity demanded of plastic? The answer is the quantity demanded will go up. And what's the definition of cross elasticity or demand? It's the percentage change in quantity demanded divided by the percentage change in the price of the substitute. So if the price of the substitute goes up, the quantity demanded of plastic goes up. Hence the cross elasticity of demand when you are considering substitutes is positive. With complements, let's take the example of let's say again pizza and soft drinks. Let's say that you cannot digest your pizza unless you are having some soft drinks along with it. What happens if the price of soft drinks goes up? So if the price of soft drinks go up, what happens to the demand for pizza? The quantity demanded for pizza will go down. Hence the cross elasticity of demand is negative when you are considering complements. We can look at this picture graphically now. What we are considering is the demand. So let's look at this demand curve now. Let's say that we are talking about the demand curve for pizza. So y-axis is the price, x-axis is the quantity. What happens if the price of a substitute, let's say burger and pizza are substitutes, so if the price of a burger goes up, what will happen to the demand for pizza? The answer is the demand for pizza will shift to the right. Now this brings another important point. Remember, I had mentioned earlier that you move up and down the demand curve if the only thing changing is the price of pizza. Here, what's changing? What is changing is something other than the price of pizza. So what is changing is the price of a substitute. When the price of a substitute changes, so that is something external to what we are analyzing, which is pizza in this case, then the quantity of pizza demanded increases. Increases means that the demand curve shifts to the right. Now what happens if the price of a complement, which is a soft drink in our example, if the price of a soft drink rises? Given that you can only digest your pizza if you're also having a soft drink, and the prices of soft drinks go up, what's going to happen to your demand? In this case, the demand for pizza will decrease, which means that the demand curve will shift to the left. Now let's try to understand the concept of income elasticity of demand, which is depicted by YED. And what does the income elasticity of demand do? It measures the percentage change in demand in response to a percentage change in income. And as we talk about this concept of income elasticity, we need to understand that economists, broadly speaking, categorize goods as either inferior or normal. An inferior good is a good where the income elasticity of demand is negative. What does that mean? That means that as your income goes up, so if your income goes up, the quantity demanded goes down. An example might be public transportation. So when you don't earn much money, you probably might rely heavily on public transportation. But as your income goes up, then you might buy your own motorcycle or you might buy your own car, and your demand for public transportation will go down. So in this example, public transportation is an inferior good. Normal goods are goods where the income elasticity of demand is positive. Within normal goods, there are two subcategories, necessities and luxury goods. With necessities, the income elasticity of demand is between 0 and 1, and you might consider food as a necessity. So as your income goes up, you consume more food, but obviously there's a limit to how much food you can consume. So the demand is somewhat inelastic. Inelastic demand means between 0 and 1. Luxury goods, on the other hand, might be vacations and so on, where as your income increases, your demand for luxury goods increases by more than 1. So a 1% increase in income would mean a greater than 1% increase in the demand for luxury goods. So that's the concept of income elasticity demand. Just as we have elasticity associated with demand, similarly we have elasticity associated with the supply curve. The formula is essentially the same. Obviously here we now talk about the percentage change in quantity supplied divided by the percentage change in price. And this number will always be positive, since if the price increases, then the quantity supplied will also increase. So the relationship will be positive. Let's understand this graphically. What we are looking at here in the top half of a screen is a somewhat inelastic supply curve. Let's see what happens when there is a shift in the demand curve. So before the shift in the demand curve, we have a situation where the equilibrium price and quantity is given by this point P0 and Q0. If the demand curve shifts to the right to point D1, so there's an increase in demand for some reason, what is going to happen to the new equilibrium price and quantity? Demand is higher, so we can imagine a higher price and a higher quantity. So that's your point over here. Notice that since this is a somewhat inelastic supply curve, we have a substantial increase in price. So the price went from P0 to P1, but the increase in quantity is relatively small. Contrast this with the picture at the bottom, where we have a much more elastic supply curve. So this is more elastic. When you have a more elastic supply curve, look what happens. A similar shift in demand, but what happens to the changes in price and quantity? So notice that here the change in price is small, but the change in quantity supplied is pretty substantial. So this is an example of a elastic supply curve. Small change in price, big change in quantity supplied. Examples of a few different kinds of supply curves. So on the left, what you see is a perfectly inelastic supply. A good example of this would be, let's say, land in a given locality. So the quantity of land in a given locality, the quantity of land supplied does not change regardless of the price. Okay, so that would be a perfectly inelastic supply curve. What you see here in the middle are unit elastic supply curves. And this might seem a little counterintuitive, but any supply curve that's a straight line passing through the origin would be unit elastic. And you can understand this very quickly if you just put some numbers here. Let's say that you have a quantity of 2 over here and a quantity of 4, and as you go from 2 to 4, let's say that price goes up from 1 to 2. So as you go from 2 to 4, the percentage change over here on the quantity axis is the same as the percentage change on the price axis. So your numerator and denominator are the same, so your elasticity is 1. What happens here on the steeper looking curve? So on the x-axis, again, you have gone from 2 to 4, and on the y-axis, let's say that you have gone from 3 to 6. So here again, the percentage change in quantity and the percentage change in price are the same. So the elasticity again is 1. So if you found this a little difficult, you can just do this on your own. You can plot a few straight lines through the origin, and you will notice that the percentage change in quantity divided by percentage change in price will always be 1, as long as the line passes through the origin and is straight. Finally, here is an example of a perfectly elastic supply curve. So perfectly elastic supply curve, the quantity supplied can vary, but the price doesn't matter. So the price is determined, and at that determined price, the quantity supplied is infinite, or can be anything. A good example of this is non-renewable resources such as oil, and we will understand exactly how that happens in a later reading. And this is the final slide for this reading, which talks about the factors which affect the elasticity of supply. The first major factor that you need to be aware of is resource substitution possibilities. What does this mean? So resource substitution possibilities, if you are supplying a product and there isn't much flexibility in terms of how you can make or supply that product. If there isn't much flexibility, then the supply curve is going to be fairly inelastic. On the other hand, if you are supplying something where you have several options in terms of how to make or produce that product, then obviously the supply curve will be much more elastic. The other factor impacting elasticity of supply is the time frame. As you can imagine, if you are talking about a very, very short term time frame, which is referred to as momentary supply, then let's say you are talking about fruits, the momentary supply curve will be rather inelastic. And you can imagine this. Let's say that we are talking about the supply of oranges, and there is a medical report that comes out suggesting that oranges are extremely healthy for you. So if oranges are extremely healthy, then what does that say? So people will be willing to pay much more for oranges. If people are willing to pay much more for oranges, can the supply of oranges suddenly increase? And the answer is, in the very short run, the supply of oranges will stay roughly the same. So if the supply of oranges is not changing, that means that in the very short run, or the momentary supply is rather inelastic. Contrast that with the longer term. Let's say it takes about 7 years to grow new orange orchards and substantially increase the supply. So clearly, if the demand for oranges has increased substantially, then in the longer term the supply can also increase a lot. So what this says is that in the longer term the elasticity of supply is much more, and strictly speaking the definition of long term is any amount of period where all possible ways of adjusting the supply are exhausted. So in my orange example, if it takes 7 years to for a new orchard to be producing oranges, that's so long term in the context of oranges then becomes 7 years. Short term is somewhere in between. So short term might be that in the short term you can increase the supply of oranges by using more fertilizer and improving the yield of the existing orange orchards, and that will imply that in the short term your elasticity is a little more relative to the very, very short term or momentary supply, but short term elasticity in the short term would still be less than elasticity in the long term. And that brings us to the end of the reading on elasticity. Your job now is to practice as many questions on this as possible.